we designed a flying tool to help save whales in Iceland. But we'll get to this later. There's more to this story. Every year, a charity called WhaleWise stations themselves in Iceland for the summer, primarily to look at humpback whales.
Humpback whales play a vital role in maintaining healthy oceans. Their movements help circulate nutrients, supporting fish stocks and the broader food web. But they're under threat. Entanglements in fishing gear, ship strikes and climate change are all putting pressure on their survival. By protecting humpbacks, we're not just saving an iconic species, we're safeguarding the health of our oceans. They need our help, and every effort counts. We love the sound of what WhaleWise are up to.
So we ventured into Putney, London, to meet with Jess from the charity. Hello there.
Hi.
I'm Ed, nice to meet you.
Nice to meet you.
I'm Sam, thank you for coming.
Thank you.
So we could start by just explaining a bit about who you are and why you're involved with the project.
Well, I'm Jess, and I basically met the WhaleWise team when I was in my final year of university. And so that's how I kind of became involved with WhaleWise, and then this specific project, which is called Scars from Above, where we're using drones to look at humpback whales and look at scars that are from fishing nets and the fishing industry.
The whales get scars from becoming entangled with their fishing gear. What risk does that actually cause to the whale?
What we're studying is what happens when they do survive with these nets on them, what happens when they do survive entanglement. I would say the main thing is they're less able to expend energy on important kind of survival and also just happiness factors, I guess. For example, breeding. They might skip breeding that year, also maybe feeding. It's almost like you can think about ourselves. Imagine if we had to walk around with like a net stuck to our leg. Life is hard as it is, but then we've got something that we're having to carry, like a big bag on our back for like years.
That would definitely
and years.
affect our breeding as well.
It would, exactly. It would really affect breeding, feeding, and just general well-being.
So, Jess and the team strap a piece of equipment to their drone called a LiDAR, represented by this fruit. Essentially, it calculates the exact altitude of the drone by measuring the time it takes for an emitted signal to bounce back. And by combining this data with the drone's photos, they can identify whale scarring and measure the whales to assess their health.
Yes, first though, we needed to see their existing kit in action, so we headed to the outback of Oxfordshire.
Yes, so armed with a paddleboard and our friend/electronics guru Francis Prime, we got stuck in.
Well, this is one of our drones called Coda. The LiDAR goes on the bottom, the GPS on the top, and then we have the battery.
It's worth mentioning that the existence of the equipment at all is enormously commendable. However, the system could certainly be optimized further.
It's not a perfect sort of piece of equipment.
Wow, it looks incredibly fiddly to put together. You know, you've got these bits of wires going to GPS sensors, you've got this really expensive, sensitive LiDAR sensor underneath.
The drone looks so slick, you know, and streamlined, and then suddenly you've got this big thing that's hanging on the end.
Do you know if the LiDAR's doing anything? Do you know if it's on and working?
So...
They don't even know if the LiDAR's capturing data, they don't even know if it's switched on. You've got to wait until you're all the way back at base and you don't know if you've got good data at all. You know, if we can look at improving that, that'll be really good.
So, plenty of room for improvement spotted already. Time to get it in the air.
So who's going to release it?
So yeah, who wants to do it? You want to? Yeah? Sounds good.
With Frankie promoted to Launchpad, we took care of deploying the whale.
She's gone out on a maiden voyage.
So we'd initially planned to use a tugboat, that Swan, to pull the paddleboard out so we could all still be on land and watch Jess do her research.
Ah, there we go. That was way more powerful. Stop!
But it turns out Swans have very small batteries.
Okay. The success levels of this are low.
Sam.
Yep.
Plan B. This for safety. This for propulsion. Once Sam was deployed as our whale simulator, is that working?
No.
Wonderful. We let Jess track him down with the equipment. We're launching.
Just gonna try and find me. I'm marooned on my paddleboard, tied to a tree with a tiny knot.
Oh, that's the whale.
There's the whale.
Uh-oh, I've been found.
Well, it's looking a little bit like it's trapped in this bush, and it's waving as well, which is I've not had that before.
After positioning her drone directly over humpback Rogers, Jess was able to get her data, and Sam could come ashore.
Okay, Mr. World, you can come back now.
It's not the most refined process, is it? You've got all this equipment sticking out from the drone and it doesn't really fit the form factor. So what ends up happening is you can't land it, so you have to catch it when it comes back and hold it when it takes off. Frankie was clearly quite uncomfortable.
It tried to run away from me there.
So you can imagine a volunteer who's new to this, out in freezing Iceland, being told to hold this thing with 4 spinning blades above their head to go and research some whales. So I think if we can help with any of those usability features, it'll be hugely beneficial.
So we gathered our testing equipment and returned to the car park, mobile headquarters to check the data.
Prise those open.
Oh, there we go.
So Jess has just removed the SD card from the LiDAR system to pull the data off. Now what that looks like is peeling this piece of tape off that's holding the LiDAR to the drone, undoing this zip tie, peeling back the electrical tape, prising apart the plastic to reveal the SD card slot here. That is so bad.
This upset us greatly.
But now we'd wrestled the memory card from its lair, we could use the data to do things. Should we measure my height on it? Can you just click the top and bottom of me?
Once Jess lined up the drone footage with the data from the LiDAR unit, she could then measure Moby Dig.
1.87 meters. I'm actually 1.78. It's slightly off, probably because I've measured the top of my hat, and I've also measured to the heel of my Wellington boot. It got the board pretty much bang on.
Once Jess has the data from the LiDAR and the drone on her laptop, it all becomes quite straightforward and she can measure the whale or Sam on a paddleboard. It's everything up to that point which is the problem.
Yes, it's very much a hardware issue. You have to dismantle this thing just to get at the SD card. There are wires everywhere that can get tangled up in the propellers and chopped in half, and you have to catch it whilst wearing a leather bird-catching glove. So a lot of work needs to be done to turn this into an easy-to-use tool. The first thing to tackle was the electronics gubbins, the brains of the thing. The electronics in Jess's version worked, but some of the components are discontinued and newer stuff is available, so we thought best to start again from scratch.
We aimed to make the new electronic system as compact and lightweight as possible, while still being easy to assemble from off-the-shelf components.
We managed to find smaller, upgraded versions of some sensors. The smaller the whole device becomes, the lighter it gets, increasing the flight time of the drone. After many iterations, we ended up with this, a super lightweight, extra thin circuit board with weight-saving cutouts to which all the components can be inserted and soldered in place.
We also added some new electronics features, but we'll go more into detail on those later.
With the main electronics direction decided, we started to look at the physical characteristics of the project.
Yes, so we both went away to come up with a concept around a 40 by 40 by 140 millimeter shape, something we knew we could fit the electronics into. Our concepts had to be easy to deploy and easy to catch for those organizations working off boats.
We brought our business advisor Raj along too, to test how intuitive our designs were from a non-technical perspective. We are in rural Bedford and we're here to test the first concepts of our drone attachment and catching mechanism.
I'll let you guess who's put theirs in pants.
I won't be touching that one.
So, you are a whale researcher, and when a whale appears out at sea, you need to attach one of these devices to the drone as quickly as you can, get it up in the air and ready to sense. Briefing over, Raj was like an excitable child at Christmas as the first concept was revealed.
Yeah.
For my concept, I kept it horizontal, and it's made of 2 bits. This tray that attaches to the drone, and then the main LiDAR bit that clips on to the tray. So in the field, you can very quickly deploy and pack away the system. I've integrated a little feature here so that this handle, which is cheap and easy to get hold of, can be easily bolted to the back. Assemble it.
Oh, okay.
Assembling the main bit to the other bit was a breeze for Raj.
This way, because there's an arrow there. Correct?
And that's it. It's done.
Oh,
Yes, but your confusing handle initially confused Raj into a state of confusion.
quite hard to figure out what to do with this thing.
True, but after thinking even harder,
Oh, okay. I think I get it now.
Raj triumphed.
I'm with you. Yeah. Good. We're off.
Good, isn't it? And now it was time for Sam to take his pants off.
Yes.
Very simple. My thinking was to verticalize and sidewaysify the whole thing, integrating the 40 by 40 by 140 shape this way as a massive grippable handle, making it safe and easy to catch. The GPS wire is housed within the Velcro strap, placing the GPS receiver on the top of the drone for a strong and stable satellite connection.
Although initially bamboozled, assembly of Sam's design was annoyingly fast.
He's quickly adjusted it, and he's ready to go.
And the sturdiness of the handle delighted Mr. Raj to no end.
Just wave it in the air. More aggressive. Do the most aggressive you can. Okay? I want to see more arm wave.
Yes, we get it, it's strong. Now let's move on.
Excellent.
Okay, time to get airborne.
We only have one Raj.
Yes, so we made sure to protect him and his $1 million smile.
I'm sure I'm being stitched up here. What am I doing? Catching the drone?
Yeah.
Excellent.
Ready?
My design was easy enough to grasp.
That was okay.
Well done.
Pretty straightforward.
But Sam spotted a problem.
Do you want to do that jiggle test that
No.
you did on my one?
Probably not.
Yeah, just do the jiggle
No.
test. So just give it a good jiggle.
This is going to break here, I'm telling you now, if I will shake this.
Anyway, now to catch Sam's thing.
Are we ready?
Yeah.
And in fairness,
Try and break it.
the sturdiness of the grip
Properly flail it around.
was pretty remarkable. Now throw it in the leg. That's quite a good bit of yours, because I can recognise the goodness in other people's designs.
I said this about
Actually, you know what?
30
I've got to
minutes
be
ago.
honest. Shall I be very honest?
Yeah?
I think a hybrid of these two would be perfect.
Anyway, we still needed to test Sam's landing legs.
Oh dear.
Raj was right. Our best bet was to combine our ideas.
So that's what we did. And in here is our first prototype with all of the electronics packaged into a single design based on our learnings.
So we went to find Jess and the rest of Whalewise to put it to the test.
We're in Iceland, home of the big blubbery behemoth.
Yes, and we're here to test our prototype.
First, we need to actually find Jeff.
Yes.
We're in the West Fjords of Iceland looking for Jess and the research team. There they are.
Hello there.
Hello.
Hi. Good to see you, Sam.
You too?
Hey,
Hello,
nice
Jess.
to see you. Hi.
And you? How are you?
Oh, good,
Once
thanks.
we'd caught up with the team, they began searching for whales while Jess showed us their equipment in the field.
Ah, lovely. Okay, so everything's still Velcroed on the top,
Yes.
GPS and battery, LiDAR on the bottom, so you're catching it when it comes in.
Exactly. So this is why we have to catch the drone like by hand, because you can't really land with the LiDAR on the bottom.
While the rest of Whalewise kept on whale watch, we whisked Jess away to reveal what we'd been working on.
First of all, do you like the box?
Love the box.
Great. We didn't
Nice
we didn't
colour.
do that bit.
We hope what's inside helps you with your amazing work.
Aww. Ooh. Oh, wow. Oh my God.
So this is what we presented to Jess.
It combines all our learnings. One major development is that we added a little display, which gives an all systems go check for the battery level, satellite lock status for the GPS, SD card check to make sure the data is recording,
And you should see it booting up,
Oh, yes, I
checking
do.
all the systems.
Yeah. Amazing.
and it even shows you a live readout from the LiDAR so you can make sure that it's working properly.
So if you start pointing that at things, you'll see the live
Yeah,
feed
if you
out.
move your hand underneath it like this, it'll tell you what it's seeing.
After 30 seconds, it goes into sleep mode with this little whale icon.
See a whale on the screen now.
So that's gone to sleep to save battery. So if you press the white button,
Okay.
then it wakes up again.
Oh, wow.
So you can check everything when it starts up, make sure it's all running, and then it goes to sleep so that it's not using excess power on the screen while it's actually in the air and no one's looking at
It's
it.
actually so cute, and I love the whale.
And also, how about this? So on the old one, you showed us you had to pull the enclosure apart to
Yeah.
grab out that SD
Yeah.
card, and that's why one broke. So now the SD card is just there.
Oh my God. God.
You could just pull it out.
So different.
Different.
In the best way. Like, I was not expecting, I mean, I had no idea what to expect, but I was not expecting it to look like this, and I love it.
The fins are actually, I mean, they look quite fun, but really they're also so you can still try and land it on the ground. And the LiDAR's recessed up a bit so that it won't hit the ground when you land it.
But if you do still want to catch it, then that's what this is for.
The handle attachment is similar to Ed's original concept, but now made as sturdy as mine.
And then you can hold it by that while catching the drone, which would be on top of this.
Okay, guys, your reveal is here.
We've refined the clip mechanism from Ed's original concept to be as strong as possible and easy to use while wearing gloves,
We'll strap this underneath the drone.
still making sure that the drone can be folded away while this piece is still attached.
The legs can still fold over it.
This is so cool, guys. I absolutely love.
Would you like to try it?
Yeah, do you want to take it for a test
I
drive?
think we'd love to, yeah.
For this device, we needed some very specific fasteners, which is where Accu helped us out. The little plastic screws holding the entire thing together are
3 by 12 mm polyfix 45-degree thread profile T8 Torx countersunk stainless steel screws.
obviously, which are super lightweight and mean we don't need to use any nuts.
For the handle, we used a PIC M5 hex head bolt, which was 6 times lighter than the original stainless steel bolt. We used Accu's screw builder tool to specify the exact bolt we needed. These details are important, especially where weight is concerned. All this weight saving equates to a greater flight time for the drone and more research.
So for the first time, Jess lined up the drone to take off from the ground.
Okay, here you go, little drone.
There's your controller.
Thank you. Would you like me to fly?
Yes, please.
Okay. So I don't even have to say anything. Are you ready, ground? Release! Woo!
And away.
And it's off. Look at that.
Yay!
Well, let's try a ground landing. then.
Okay, God,
Same
I've never
spot.
done this before in my life.
Look at the little fins as it flies in. Here we go.
Whoa.
So what do you think after the first
I
flight?
think it's amazing. Yeah, I love it. I really love it.
We tested the new easy catch system too.
Right, let's see if it's easier to catch.
Get the drone! Overall, yeah, as I said, had no idea what to expect. I love that you've done it as a whale. I think, yeah, the lack of wires is amazing. I think this is super cool, this little screen that you've done. And this is a really good idea as well.
With no whales spotted, we all headed back to the cars. But we were thrilled the new device worked, at least in theory.
I think it went very well. But as we romantically drove off into the sunset, everything suddenly got very exciting.
Wow, look at that. Get some footage of that. That's incredible. Oh my God. Get an SD card in the drone as well.
Yeah.
With the light, that looks amazing.
Crazy.
That is awesome. That's a magical sight. Look at that. Right, let's do something.
Okay.
So we've spotted whales out in the bay. So while they've gone for a dive, we're going to get the drone up, ready for when they resurface.
Yeah, this will be the first real-world test of the new system with some actual whales.
So if I wake it up,
Yeah.
it's still searching for GPS, so we'll wait for that.
Yes, we have satellite.
Okay, we've got a GPS lock.
Take off.
Whee, goodbye. Yay, see the whales, you see?
There we go.
Okay, let's go.
Oh, look, all three at the same time. The view you get from the drone is ridiculous. And it's all seemed very theoretical up to now, up until I saw your screen just then, and there are 3 mammoth objects gliding through the water. It suddenly became very real.
Exactly.
Oh, so this LiDAR, this new LiDAR will be amazing in terms of just making the whole process smoother and more efficient and user-friendly. Amazing. They've all gone for a dive. So it's time for me to take the drone back.
Amazing.
So, the thing worked.
Well, it didn't fall off the drone. To make sure all the electronics functioned properly, we visited WHASER's coastal base to check the data.
Right. Here is the device that we flew yesterday.
Time to see if it actually worked.
There we go. There it is. So if you get the SD card out and see if we've actually recorded anything useful whatsoever.
Let's see. Okay, so here it is.
That looks like data to me.
It does. It looks really good.
Well, one thing I will say, it looks like it's collected data. Can we actually do it with the footage and measure the whale? Because if it comes out and says the whale is 200 meters long, then maybe it's not quite worked.
So here we have the whale from yesterday, one of the aerial images, and we put the altitude in, and then we can look at the measurements. So here we have the length, and it says that this whale was 10.24 meters.
It has scaled that whale at 10.24 meters,
Yeah.
and that sounds about right for that whale.
It does.
Okay, perfect. We have scaled the whale.
Amazing. So everything worked, but it was a bit too ugly, big, heavy, and ugly.
So after a whole bunch of 3D printed iterations, we ended up with this. The final design.
Here it is. We've refined the design to be even more whale-like, because why not?
The main body has internal features to perfectly house all the electronics, all held in place with the top part, secured with lightweight, self-tapping screws.
We've lightweighted the tray piece too, and optimized the clip mechanism. Woof. Compared to the first prototype, everything is much smaller. We achieved this by tightly arranging the electronics and having very thin walls.
And we've displayed the information on the screen as icons, so there's no language barrier.
It can still use the optional handle, and it's now more weather resistant.
The SD card and USB-C charging ports are safely behind a rubber bung.
So nothing will be exposed to the elements anymore.
So, mission accomplished.
It's been a brilliant adventure, from meeting Jess in the cold of Putney to meeting Jess in the cold of Iceland and everything in between.
Yes, and we've now delivered one of these to the WhaleWise team, and the system is now available to any research organisation that needs it.
So thank you to WHASER, MPB and Accu for making this possible.
Thanks so much.